Ladies and gentlemen, good afternoon to all, wherever you are, and a warm welcome to the third day session. With us today is Dr. Ishani Patharia, Assistant Professor, Department of Commerce, and she is going to address about the various aspects of Thank you, sir, and sorry for interruptions. I'm happy to introduce today's resource person. She has a wide knowledge and experience in the field of research and teaching. She has completed her PhD on green purchase behavior, that is in the field of commerce, after completing her MCOM and MBA marketing from Maharshi Dayanand University, Rohtak. She has completed a major project titled A Study of Corporate Social Performance in India and its drivers, which is awarded by ICSSR, the premier research awarding institute in the country. And to her credit, she has been awarded by Professor Manoeuvre M. Shah Memorial Research Gold Medal for the best research paper for the empirical researches in the area of marketing. This is one of the dreams for every researcher in the field of commerce. I congratulate Madam for this at the 70th National Annual Conference of Indian Commerce Association held in Jaipur in October 2017. Her work experience has spanned from various colleges over a period of 12 years, and she has been working as assistant professor at Bhagat Pool Singh Mahila Vishwavidyalaya, Kanpur, Kalan, Sonipat since April 2012 till date. Earlier, she was a faculty at PG Department of Commerce at GVM Girls College, Sonipat since 2008. Her skills are ranging from she has been delivered more than 90 lectures on research and quantitative techniques used in research at various institutes of national stature and repute, like Maharshi Dayanand University, Rohtak, Garhwal, DAVCC, Faridabad, Geetaram International Bhushan School, New Delhi, and many more institutes. Her area of interest is research, and our interest areas are green purchase behavior, corporate social responsibility, and other issues related to sustainable development. On behalf of Government Ramnaran Chalaram College of Commerce and Management, Bangalore, and the organizing committee and the principal, I welcome you, Madam, for this third day's technical session. And I also welcome all the participants from all over the world for this faculty development program. Now I request the resource person to take over the session. Thank you.
I'm humbled to get this opportunity from the organizers to share the little knowledge with you, whatever I have regarding the statistical tools and techniques for research. And the word of caution would be that anybody cannot be 100% an expert of any area. So whatever I am going to share is the knowledge that I have, and I'll try to deliver my best to all of you. And you may put up your queries accordingly in between or afterwards as you wish. To begin this journey, the key takeaways or the highlights that you will have to the day are basically related to, that is, what are the most important things. That statistical analysis is okay, but many of the times we have already done the homework and then we are stuck in between that what we had to do and now where we have landed. So before taking up the understanding of the various statistical tools and techniques, that where we can use which statistical tools and techniques, it is very, very important that we prepare us before going in for the analysis or before actually designing the study. So you must have the know-how of the various techniques in general, which are related to your topic and which have been explored and which have not been explored in your area. So we'll be talking about that. What are the words of caution with regard to that? That what are the things you should take care of while designing your study so that you are able to apply robust statistical tools and techniques in that context. Then we will talk about what are the factors affecting the choice of tests. So it will be in the form of a flow chart, that what variables you have taken, on which scales you have taken, what are your research questions basically, on the basis of which you can stream down to actually which statistical tests would be best applied in your scenario. So then we'll be later talking about the statistical tests which are available for univariate analysis, bivariate analysis, and multivariate analysis. Then we'll also talk about some of the other statistical tests which are very popular nowadays, which are upcoming in the recent studies in various arenas. Although my title was restricted to the choice of appropriate statistical tools in business research, but as the organizers told me that we have the participants from different streams, that is agriculture, medical sciences, finance, and so many other fields. So I have biotechnology. I have tried to put all the tests which can be applicable in various streams of study so that you can relate it to your arena of studies, your domain of studies. Firstly, every researcher must know that what is the purpose of doing the research, that why they are doing this research, what they are trying to basically find out this research, and how they would be doing this research. In that sense, that whether they want to see the differences through performing the experiments, whether they wish to know what exists, and actually after doing that, that what can be predicted on the basis of what actually exists. So broadly, if we say that all these statistics can be classified around two streams, that is, one is descriptive statistics, which tells us about what is the nature of our data. It is very important to have appropriate nature of data, to understand the nature of the data for the selection of appropriate statistical analysis techniques. And that means that the historical data which is available, or the data which we have collected, what has been happening in the past, that looking towards the past, such statistical techniques are known as the descriptive statistics or the analysis, which becomes the pavement for or the building block for the inferential statistics or the analytics which is related to, that is, we are here going to predict something about the future on the basis of the analysis, on the basis of the nature of the data, on the basis of the relationships which exist in the prior information that we have collected or we have with us, right? So basically, descriptive statistics means that we are trying to draw conclusions about the sample so that we can make certain assumptions or we can make certain declarations about the population as a whole, right? So it gives us a general impression about that what exists in the population on the basis of the sample. In this, the various techniques which are used are frequency graphs. Likewise, you must have studied, those who have studied statistics at any point in time must be aware of that the basic work we do is whether if we want to find out the differences or whether if we want to find out the relationships, we always plot graphs so that we have a general idea that what kind of data we have and those graphs are again selected on the basis of the nature of data we have. Nature of data here basically means that whether we are working or talking about the categorical data, the non-metric data, or the metric data. And then again, when we are talking about the metric data, whether it is homogeneous or heterogeneous, whether it is normally distributed or it is not normally distributed, because this all becomes the basis of selection of the future tests, that whether we will be going in for the parametric versions of the tests which are available or the non-parametric versions of the tests which are available. Because if the data is homogeneous, if the data is normally distributed, then only we can represent it through mean, or we can do the mean-based statistical analysis on such data. Similarly, if it is not homogeneous, if it is not normally distributed, we will go in for the median-based test, median-based statistical analysis. Again, if we have the categorical data, what can we do? We can only have the relationships in the form of, this means that we are talking about the categorical data, there we can work on the frequencies. So when we talk about frequencies, we will be going in more of the tests which are based on the modes, likewise chi-square, which looking for the associations rather than the relationships, robust relationships. Similarly, while talking about the measures of dispersion, that would again let us know measures of dispersion, measures of variation. These are all the indicators for going in for the future analytics, in the sense to study that whether if the data is skewed, if it is not skewed, then which variant of which statistical test will be applied over there, whether it is more of the normally distributed or whether it is not. It also helps in data cleaning, because more homogeneous the data we have, or homogeneity in the sense of the groups which we are going to form, there are no outliers, then only the prediction ability, or you can say the predictability or the reliability of the power of the test would be higher. So it is always suggested to have the descriptive statistics analysis before going in for the analytical part or the inferential statistical part. Am I clear so far? Organizers, will anybody, I want it to be a two-way interaction session. So will they be able to unmute themselves or ask the queries, or all the queries would be taken at the end of the session as you suggest? Okay, I think it would be at the end of the session. So further, once we have taken up the descriptive statistics, then only we can go in for the further inferential statistics, which is basically more reliant on the hypothesis testing. Hypothesis testing here means that we are making assumptions about the population, because here we cannot actually have whole of the data or the survey analysis. So we are working on the basis of samples and we are going to make the predictions about the population. So when this is done, we basically, all the research moves around the hypothesis testing, and these hypotheses need to be framed very clearly. We will be talking about this again later, that in the sense they should be robust enough, they should be substantive, that they contribute new arenas or new dimensions to the existing research. They should be based, they should link the past with the future. So one general idea that which statistical techniques or tools will be used in your particular research is based on the literature review. As Professor Dalip told in the first session, in the on the first day of the workshop, that literature review, or rather speaking, the systematic literature review plays a very, very important role in determining various aspects of the research that we are taking, because they help us to move to understand where we stand and where we can go. What are the future directions where we can go? And it is standing on the shoulders of the pillars, basically. So one easiest of the way to have a general idea that what kind of statistical tools and techniques will apply in your context is to do with, that is, making a systematic literature review of the variables that have been used in your particular study. This particular slide is one of the examples of a research which is based on internet banking adoption in that sense. So here they have taken the various variables which have been used in the context of the companies, with how they are using it, right? And then they can talk about that these are the banks basically which have been studied in this context, and the sample size, and accordingly which techniques have been used. So here we can have the idea of the various variables that can be used, not only the variables, how they have been measured, and apart from that, which techniques, similar techniques have been used in the past with regard to this. So the basic decision-making process, how it can be done is, that is, firstly, one must decide that what do they want to do? That is, what questions basically your research will address, that we always talk about in the context of research methodology, in the context of research questions. So here the objective can be to explore the effect of age on willingness. So similarly, it can be measured in various aspects. Whether we want to see the effect of age on willingness can be studied through whether both the continuous variables like age also in number, willingness also, that is a summative score or the factor score of a scale, and then we will have the number or metric data on both of the sides. So we can basically have the relationship between the two variables. So that will show the effect of age on willingness. But we can use various techniques over here in the sense of which are robust in the form of linear regression or the Carl-Pearson moment coefficient. Then we can have the data in the form of, if we want to address the same objective through the question that whether older people are more willing, or is there any significant difference in the willingness of two particular age groups. So there the statistical test will be related to, that is, comparison of two groups. That is, that would become the test of differences over there rather than the test of relationships as it was discussed in the first question format. Otherwise, it can be, is there any significant difference between the various age groups? So here it will again become the question of the differences, and here the number of groups being compared will be more. The levels of comparisons will be more. So different type of statistical tests will be applied over there. There are so many other questions which can be framed in this context, that whether you want to watch the effect of age on willingness, controlling some other variables on. So therefore, you should be very clear about the questions that you are going to address through your research. Then what type of research design are you planning for that? Whether it will be experimental, that is, whether you are working in the controlled experimental group. For the case, like I had talked about the effect of age on willingness. People from agriculture, they can have the context of, that is, irrigation on the yield. Yield can again be measured of n number of ways, that is in the format of quality, it can on the parameters of the quantity, and similarly irrigation can also be measured in the numeric form or in various categories, and whether it will be controlled experiment, that is different treatments would be given by the researcher, or it is actually that the groups already exist in the real nature of the data, like comparison of males and females, this age group like I was talking about. So what kind of experiment are you going to conduct? How many categories you are, how many variables, or how many treatments you are going to give over there? Again, when you are talking about the survey data, so that has a different level of techniques to be applied on it. Rather, like if we see that Anova, Manoeuvre, these are all the techniques which were usually and traditionally being applied on the experimental group. Whereas if we talk about regression, such techniques are more to do about the survey data of the classifications which already exist. Then it can also be through observation. Then again, it also has the similar aspects that the statistical tools used in that context may be a bit different from that compared to those in the other research designs, but they can always overlap with each other. There is no distinction to that. Like I said, that Anova, Manoeuvre, these were basically used, Manpova, these were basically used in context to the controlled experiments. But now, these days, that is widely being applied by the already existing groups, groups, or by the marketing researchers, by the finance researchers, that they are not giving the treatment already exists and they want to compare the groups. Then what are the key points that should be taken care of while doing any of these research designs, so that you are able to satisfy the assumptions of the robust or the parametric versions of the statistical test? So in that sense, you can, while you are performing an experiment, you should divide the groups. We'll talk about this in the coming slides also, that what are the benefits of doing so. You should decide whether you will be going in for between group designs, that is the groups that you will be taking. For example, doing research on student psyche. It may be that you are taking students of different schools of the same grades, or same school of the have in studying in different grades, right? And likewise, studying people who you are trying to compare the perception of the people in different metro cities. Or it can be a repeated measure design, in the sense the respondents are the same. That is, you have a greater control on the variables which are not even being confounding variables, which are not directly being considered in the actual experiment. Likewise, I gave the earlier examples, comparing two grades or comparing the students from two different schools, they come from different backgrounds. So that may be one of the intervening factors. But when you conduct a repeated measure design experiment, that the same students, before conducting the experiment and before giving the treatment and after giving the treatment, so their background characteristics are obviously controlled. So you will be able to apply different set of techniques in these two cases. Then you should always have enough level of categories in an independent variable if you are talking about the experiments or the categories you are going to compare over there. And it is always better to have a control group or some control variables, because again, the explanatory power of the model or the study increases, and your error term, which is the difference between what you are trying to predict and what actually exists, that steeps down when if the robustness of your study or the results or substantiveness of the results is studied in near future. So more the merrier, more the variables that you can handle, you can understand, which are existing in the relevant literature, or you have considered through observation, giving novelties to your study. So greater the variables, the control groups, the confounding variables, better will be the predictive power of these statistical tools. Again, in case of surveys, you must always consider greater number of participants, because they may be left out. There may be some outliers in responses. So there is not homogeneity, and the results will not hold good for whole of the population. So you should have clearly defined population over there. And apart from that, if you are considering various groups for their comparison, they should be rather comparable groups. Enough of the participants in each of the groups, whether you are doing an experiment, whether you are doing in a survey, and when it is more related to human behavior, rather than such as the yield in the case of agriculture or some other areas, the study of bacteria, genetics, there the behavior is not so unpredictable as compared to humans. So you must to overcome the go error, basically, or the drop error, you should include more of the participants in each group, and ample groups should be formed of it. So this will also reduce the problem associated with non-equivalent groups in between group designs. And again, many of the assumptions which for many of the statistical tests which are not satisfied, they are overlooked when the groups being compared are equal in sizes. Apart from that, for the same outcome variable which you are trying to predict, you must have ample or different measures as dependent variables. For example, for a person of finance, if you are doing the study over there and you want to measure the performance, financial performance, so you can have various measures, that is some of the book related measures, some of the book-based measures, market-based measures, ROE, Tobin's Q, market capitalization rate. You should have ample or different measures for dependent variables, because some measures are more sensitive than others, and it becomes diversity to your contribution to the arena. Similarly, if we talk about in the case of some other cases, like in the sense of medical sciences, if you are taking the dependent variable as health, then it can be the physical health, the emotional health, and various measures for having it, because different measures may be more sensitive than the others. I've already told that you should take as many as variables in your study so that you can consider the possible influence of extraneous and the confounding variable. But sometimes it is not necessary, because in marketing, in finance, where we deal with the companies, we deal with the people, then that needs to be taken care of more. But when we are doing experimental studies, there again, there may be not so many extraneous or confounding variables, or the purpose of your study, as I told you in the very beginning, whether your purpose of this study is to see the relationship between the two variables at a time, ignoring the effect of the other variables, or you are taking into view the two variables controlling the effect of the other variables too. So in your arena, again, you can always look for the possible influence of extraneous or the confounding variable. In this sense, like, I have divided my study, my lecture in basically three forms: univariate, bivariate, and multivariate. So, but again, understanding of the bivariate studies, that is relationship between two, rather than having the confounding variables, is again very important for the understanding of the multivariate techniques, because the same assumptions or the same conditions apply or are extended towards the multivariate analysis. Now, while designing the questionnaire items or scales, you should be very cautious whether you are using the standardized scales, because then you have not to put so many of the efforts regarding the validation of the scales. But if you are again using what are the items and scales you are using, they should have some reasoning from or some support from the review of data. And from the point of view of the statistical analysis, it is always better to have a pilot study, that is full testing procedure before, and in the midway of the complete data collection, you must apply or try to apply the future techniques, probable techniques, which you have already thought of on the partial data which you have in hand, so that you get some sort of picture that whether your data which you are collecting will fit into the framework of the statistical tools and techniques you think of applying in the future. Otherwise, you need to again go and recheck the items and scales you are using, because that does not fit to the need of the statistical analysis techniques. You need to check over there. For again deciding over the best statistical techniques which may be applied, you must have the clear diagrammatic view or the clear relationships you are going to study, that which one is your dependent variable, which is your independent variable. In the past, even if they have been taken as dependent variable or independent variable, can there exist actually the interdependent relationship. Is there any logic to interdependent relationship between the variables which you are studying? And again, nature of variables, whether it is metric, non-metric, normality, how you are actually going to collect the data for the same variable, which can be taken in n number of ways. Then further, you can go in for checking the assumptions, and by if the assumptions fit, you can have the parametric versions, and if do not fit, and the conditions, additional conditions even do not fit for the parametric test, you can go in for the non-parametric versions. I have prescribed some of the resources over here, that in these books, it is given in very simplified manner how you can get to choose the different statistical tests. What are the different statistical tests? Apart from that, I would like to share that one of the websites which provides you resources for research, that is data analysis examples with statistical tests. These are the two links where any researcher can go in and have a general idea that where to use which test, that what is the nature of your independent variable. You can go into the set criteria and you can check that what is the nature of independent variables, how many independent variables you have, how many categories they have, how many dependent variables you have. And again, they have various softwares through which they show that how you can apply these tests, even the multivariate types. So this is a very resourceful website link where you can actually go and study at length, because in 2 hours we cannot cover each and everything over here, but still I will try to cover most of it, whatever techniques. So many of the techniques are available here. You just click and you can get to learn about those techniques, how they are applied in a particular software. That is also available over here. Can you see the, okay, I think you are all on mute. So I just hope that you can see this website. I'm just showing you. See, this is basically the website. And here you have different resources which are available free of cost. That is which statistical test you can use. Or likewise, the examples for each, how they are used, what are the steps, what are the conditions, everything is available, right? Now, as I told you, what is the purpose of your study? That needs to be determined very early and very clearly, precisely, why you take up your research, because that will again determine that which statistical techniques you are going to use over there. Whether you are going to study the differences, whether you are going to see the effects. Effects means in the sense of the consequences, or whether you are going to measure the impact, that is the influence of the outcome of the effect which it has. For example, using these terminology, maybe as an ecological scientist, you want to research for, at the agricultural scientist, you want to research over that there is global warming. Global warming has the effect on the various aspects, climatic aspects, like in the sense the temperature, the humidity, the irrigation facilities, in fact, indirectly. And then if you want to see the impact, what all these things have the effect or impact, in particular, the measure of the effect they have in particular of these outcomes on basically the growth of the plant, the quantity of the yield or the quality of the yield. So you need to clearly define the questions and related the hypothesis. Again, hypothesis, whether it would be a directional hypothesis, or when we talk about usually the two-tailed hypothesis, that you do not know priorly. You are designing a hypothesis that how much effect or what effect it would have. It would have positive effect or negative effect. Then if you have it clearly that it would have a positive effect or negative effect, then in that sense, that what would be the measure of that effect or the impact in particular, controlling for the all other factors which are related to that particular phenomenon. You should have a clearly defined population, because if the population is not clearly defined, you will not be able to get an appropriate representative sample, and there may be problems related to homogeneity and further the production, because prediction power of your models or the statistical tests, because the population needs to be clearly defined, that if you want to predict about the organic consumers, which type of people you will be approaching, because having different diverse age groups or having the people for different organic products, the perceptions may differ. So the more the specificity of the population, better will be the choice or the results of the statistical test. Then sample, again, you have to think of whom you are going to study, why you are going to take that sample, then what will be the appropriate sample size, and then you have to add some contingency individuals or items to that sample, so that you have the enough of the sample, even if you are trying to drop some. Then how many, that what I told, that is size of the sample, right? So we take the journey further. So this is the simple steps of, or the procedure of the hypothesis testing we have been studying so long, that firstly, on the basis of the review of literature, we will try to pose something or assume something about the population, whether that is in the form of the, basically we are more interested in the alternative hypothesis, because null hypothesis is always about there is no relationship between the variables being studied, or there are no significant differences between the two phenomenon or the two treatment groups, or more than two treatment groups which we are considering for the study. Whereas the alternate hypothesis basically can state, which is the directional hypothesis usually, if we have a prior know-how that in which direction the dependent variable will move, or otherwise, as I told you, that the elderly people more willing, or they have the greater intention to purchase, or you can say in the medical sciences or the agricultural fields, that the treatment you are giving, the one treatment is better than the other, then it will become a directional hypothesis. And if you just talk about that there is no significant difference in the dependent variable on the basis of the treatments being given, so that will be a non-directional hypothesis, that is two-tailed test. So although the same statistical test apply, but it is just the computer which is applying the test, but it is the humans that have to make the predictions. So your prediction should be well defined, and sometimes again the level of significance and the results, p-values, they need to be manipulated in context to the type of hypothesis you have framed, because every software would not give you the exact value in the sense of two-tailed or one-tailed hypothesis. After that, you always have a suitable level of significance for yourself. The more the confounding variables, you can say the higher will be the level of significance, in that sense that you will be applying for the error rate in those phenomena. For example, if we talk about neurosciences, medicine, there we need to control the more of the error, that the level of significance will be 1% around. In case of the humans, it can be around, or agriculture, it can be around 10%. In case of most of the social sciences fields, economics, we assume it to be between 5% to 10%. Then you have to have the reliability and the validity check of whatever the scales you have used in your study. After that, and just understanding that what is the nature of the data you are playing with. And apart from that, then you can go in for the suitable test of statistic that you will be using, the critical values related to that. And after the calculation, you have to make the decision. And decision is again based on the hypothesis you have taken. And decision here is not only nowadays confounded to that there is a significant difference, there is a significant relationship, but it has gone farther to that this significant difference, what is the effect size of that significant difference, how it can be have a multiplier effect in the population, or the data, the surroundings, or the setup in which you have conducted the study, how generalizability, how large the generalizability it has. Significant difference, it can be of 5% only, But how big, how large the difference is, that is again very important while giving the decisions. That is the calculation of the effect size, the post hoc test. These are very important phenomena nowadays if you consider about applying the statistical test. Broadly speaking, the choice of test, as I told you that we were discussing about, this was about what preparation you have to make for choosing the appropriate statistical techniques. Now we will be talking about what are the factors basically which affect the choice of the test. That I told you that you should have a diagrammatic representation for yourself while you are going in for the choice of the test. Some of the easy criteria I've already discussed, that you can have a view from the review of literature, but just to counter check and the cross check that which are the most appropriate statistical techniques for you. Firstly, you will go in for that what is the purpose of your statistical analysis, whether it is about testing of the differences or testing of the relationship. Testing of the differences has to do about where you have groups, two groups, more than two groups, and the dependent variable is rather, it can be in the form of, that is independent variable is usually non-metric, that is it is categorical. You need to study the differences. That is the independent variable is a categorical variable, whereas the dependent variable is more of the continuous or the metric in nature. Testing of relationship can be included in the sense of when we are talking about the relationship between the two non-metric concepts, then it would be more be of the form of the test for the association. Broadly used as the chi-square test used over there. That is the frequency test used over there, because there both the data is the relationship between which the type of data between which you are trying to find out the relationship is the categories or the nominal type of data or nominal ordinal, nominal scale. So such type of data. So different techniques will be applied over there. So the other techniques which are related to the ratio type data or metric type data will be totally ruled out. So while framing the studies, that has to be taken care of. And again, while checking, having a check for the statistical test you are going to use, it depends largely on the purpose of the statistical analysis, the level of measurement, number of set of samples you are having. It is two groups or one group. That is, one group means sample comparison with the population, or the two groups or several groups over there that you have given. If in the case of experiment, you have 3 treatments or one control group and 2 different treatments for the consideration. That is 3 set of samples over there. One is control and 2 are of interest. Or otherwise, if you are comparing, likewise, you want to compare the performance of the banks. So it can be public or private banks, 2 groups only, or it may be public, private, and foreign firms. Agriculture, again, as I told you. Medicine, again, as I told you, control groups. Then the level of medication or the level of the treatment given can be 2 or many, and that's it. Then set of samples, whether they are related or independent, because the same people or the same object is being tested time and again, that is related. And if different groups are given the treatment, that is independent. And on that basis, we further analyze that whether we will be going in for the parametric test, non-parametric test. Parametric tests are basically focused on the distribution. They have a major assumptions many of the time that the data should be normally distributed. Which kind of data can be normally distributed? Metric data can only be normally distributed. We never check for the distribution in case of the non-metric data or the categorical data. Likewise, many of the researchers have the confusion over there. When you are working on interval scale, the summation of the data becomes the complete metric data, where you can have pure numbers on the continuous form. Whereas when you talk about the single statement, it is hard to apply the parametric tests over there. The non-parametric versions of the test or the different criteria of the statistical test will be applied over there. Whereas a non-metric test, you can largely apply it on the non-metric independent variables or the metric variables which are not normally distributed. You apply the non-metric test over there. Measurement level is rather, as I told you, interval or ratio. Here it is nominal or ordinal. Therefore, parametric tests are usually based on comparison of the means. Like if you are considering the dependent variable on a continuous framework, that is perception of the people is the dependent variable, and the independent variable are sort of two groups. So if the perception in each group is normally distributed and it is comparable, that is, they have the two groups which are being compared, they have homogeneity of variance, there is no significant difference in the variance of the two groups being compared, then you can easily go in for the parametric test. But even if these assumptions are not satisfied, there are certain other conditions which are often specified, means there are larger specific assumptions or the restrictions in the parametric test. That is what I said, that if they are equal groups, then this condition of normality, if violated across the groups, still you can go in for the parametric test or the mean based test. But if these assumptions are not satisfied and the additional conditions are again not satisfied, they were not two equal groups, they did not have equal variance, both of the data was not normally distributed, then we have no option left but to go in for the non-parametric tests. Parametric tests are usually known as the more robust category of tests as compared to non-parametric tests, because they have more of the predictable ability due to the homogeneity and the normality conditions over there. Applicability, where it is basically on variables. This is basically on variables and attributes also. Now we are starting with the main journey of discussion of what are the various statistical tools available and where to apply which test. Usually in the field of social sciences, we do not go in for the univariate analysis, but still we can go for univariate analysis. How? That is, if we have a known population parameter. Likewise, we know about the mean of the population, or there is some sort of declaration through a renowned and reliable source that on an average, Indian companies increased their performance by this much level, or their profits have gone up by this by a particular number in crores or in percentages, in any format, that is a number, and we want to test it on BSc 500 companies or a group of BSc 100 companies. In that context, again we can compare the sample mean and what has been posted or what is for the population for the previous year data can be compared with the this year data on the basis of the sample if you want to wish to do it. So univariate analysis is always about, most of the times about, not always, most of the times about comparing the sample statistics with the population parameter. Parameter here stands for the statistical measure for the population, which is either hypothesized on the basis of the expertise or which is available through some reliable source. So when we want to compare the observed probabilities to the hypothesized probabilities, then we basically use the chi-square goodness of fit over there. That is, in the sense, if it is said that a market survey says, I am a person of marketing, so I'll be quoting more of the examples, maybe inadvertently, of marketing, but you can always relate it to your field. Likewise, there is a popularity survey, and it shows that most of the customers, how many customers go in for brand A, how many customers go in for brand B, how many customers go in for brand C. What is the purchase rate across these three categories, right? So the data is nominal in the sense that here the number shows that is actually not the number, but it actually shows the number of people who are using a particular product or they prefer to use a particular product. You cannot multiply that number, you cannot divide that number. That would not exactly show the popularity or the choice in that context, right? So it is the frequency you're talking about, because here brand A, brand B, brand C are being studied. So in that context, if you want to check through your sample whether the popularity is the same in your area regarding the investment avenues, regarding the brands, so you can always do it through chi-square goodness of fit. That test is available. One of the important assumptions regarding various tests is various statistical tests is that the sample should be random. Randomness here means that if you are collecting the data, you are not going in for more of the males together, more of the females together, collected data from the same locality. So in that sense, the nominal data or the demographic profiling of the data can help you prove for your sample that whether the data randomness is there or not. For that, we have a non-parametric test that is known as the run test, that is Wolfowitz run test. Then if the data is ordinal in nature, and again you want to compare it with the with something that exists for the population, that is brand one, this is brand 1, this is brand 2, this is brand 3 in the market, and the people, you have taken the rating from the people in that context, and you want to compare it with the population, then you can again apply chi-square goodness of fit over there. If you want, if the data is not normally distributed, it is in numbers, so you will go play with the median, not with the mean. So in that sense, instead of applying the higher order test like the t-test, which is available, you may apply for the Wilcoxon signed rank test. In case of interval, again, if you want to compare the sample mean with the population mean, likewise, if they have you have a scale, 7-point scale, and you have taken a mean over there of the choices or the respondents' perception towards something, and you have a hypothesized value that you wanted to show it is more towards the agreement or more towards the disagreement. So you have a hypothesized value in that sense. If you want to compare it, you basically do it through the t-test. Otherwise, if you want to compare the median, as I have told you, that can again be done with the Wilcoxon signed rank test. There is median test also available, but Wilcoxon signed rank test is the more popular test as compared to the median test. If the data is on ratio, the example initially I quoted regarding the performance, if it is normally distributed, then again mean-based test, otherwise median-based test. If you want to compare the sample variance to the hypothesized variance, if it is available through meta-analysis, sir had talked about this technique in the first day of the workshop, that you derive the numbers, and we will be talking towards the end about this probably. That is that if you have the values or the statistical measures for the population on the basis of meta-analysis, that is synthesizing the statistical measures which have been conducted in the previous studies, and you want to compare that population variance with the sample variance, in your case, it can be done through, again, the chi-square test, which is again the parametric version of the chi-square test. Usually we want to check the normality distribution condition. So that is basically test through two non-parametric tests which are available, that is Shapiro-Wilk test and Kolmogorov-Smirnov test. Kolmogorov-Smirnov test is applied where the number of items or number of the participants is more than 50, more than equal to 50. And if we want to check for the cases under study, the items under study are less than 50, we go in for the Shapiro-Wilk test for checking the assumption of the normal distribution. So this was all about univariate analysis. I hope you can just relate to your own context and your own studies, in the sense, this is from the agricultural background. If we have the people, that can be in the form of yield in numbers, yield in quintals, right? And the hypothesized number, right? So this can be done in that way. Now we move forward to the bivariate analysis, and again still holding on to the story of differences, whether there is a significant difference in the two categories, only two categories. That means in the independent variable is categorical, and we have only two levels in there, that is male, female, that is adults, non-adults, or that is exclusive groups in that scenario. Or if that is not the exclusive groups, it is the groups that is before, after, only one treatment, not more than that. And the dependent variable is continuous in nature. So as I told you in the beginning, that for the parametric test, one of the important conditions is that either you have the normality across the groups being compared, normality of the continuous variable across the groups you're going to compare, and also the homogeneity of variance. But if these two conditions are not satisfied, again you have equal members in each group or equal cases in each groups you are going to study, still you can go in for the parametric test. So if we have two independent samples, like I talked about males, females, or the same level of people from different grades and different treatments being given over there, then we can go in for the parametric test, that is the t-test. Otherwise, its counterpart in non-parametric test is Mann-Whitney test, where the data should actually be at least on the ordinal scale. Then, if we have several independent samples, the extension of t-test is the Anova, where the dependent is, this is again multivariate context. This is the multivariate context of the bivariate context that you can apply Anova over there. We will talk about these techniques when we will talk about in context to the higher levels. But again, in that sense, it is still considered the family of the bivariate because here we have two variables. When we talk about the variables, in the sense this is two variables, but in two variables, in this independent variable, we have multiple levels. But if we had more than two variables, multiple levels, then there is another technique in the multivariate context, that is in the sense of Manoeuvre. So again, why this has put in the category of the bivariate test? Because there are two variables. One is dependent, that is continuous scale, independent, but more than two categories. Here, independent has only two categories or two levels which are being studied. In context to, again, if the assumptions of Anova are not satisfied, we can go in for the Kruskal-Wallis edge test. Why I said that it can again be taken in context to Anova can also be taken in context to the multivariate analysis, because it plays a very important role wherever we want to go in for the regression part, that it actually decides the robustness of the model, because its function is to check between the explained and the unexplained variance of the group. So we'll also talk about this later in the multivariate analysis also. Then if we have two related sample means that is the categorical group which we are talking about is the same cases or the same people at different time zones, on different time zones, but there are only two time zones. That is one before, one treatment, and the second, again, we have taken the observation. That is two related samples. Several related samples means that the dependent continuous scale observations have been taken after multiple treatments. Likewise, that is the controlled before the treatment, first treatment. Then we have taken the observations. Then again, we had some other treatment on the same group. And then we have observed for the differences. Likewise, in the case of medicine, initially, what was the condition of the patient? We have some parameters. Then we gave him a particular treatment, some medication, and then we noted down, now what are his health parameters in that context? And there is a single dependent variable, mind it, because if there will be multiple, then we will move to different categories, because dependent is single here. And then we have given him some different treatment and then again taken the measures. That means repeated measure Anova, right? That is several related samples. That is across different time zones, more than two time zones. And if we talk about the bivariate relationships, this was all about the story of the differences. But if we want to talk about the story of the relationships, that would be done through the Pearson product moment coefficient, Karl Pearson product moment coefficient, which is very popular. And the non-metric versions for this is the chi-square test of independence or the Spearman rank order correlation. That is, it is usually done on the ordinal data. Or otherwise, if we, there are various other the correlations also we'll be talking about. Kendall tau is also there. So we'll discuss in detail over there. But usually if the assumptions for the Pearson product moment is not satisfied, we go in for the Spearman rank order correlation in that context. So these are the various tests available. And I have tried to depict it in this sense. Now we'll be talking in detail that where to apply which test, choice of the test. So one sample t-test, as I told you, in the univariate analysis, it is applied when we want to test the assumption that whether there is a significant difference between the sample mean and the population mean. So theoretically, it is used when sample is taken from a normal population and we have unknown standard deviation, but we can predict the mean, or it is hypothesized in context to certain robust observations. Then we have, as the variant of t-test, we have independent sample t-test, where the two groups are totally independent, that one case cannot fall in the other group, like males and females, I told you, pass and fail, I told you. There is no overlapping between the two. And such groups, or the treatment being given to the individuals, they are totally different. There is not a single individual who is getting the same treatment. So there we have independent sample t-test, where we want to compare the mean of the observation of the variable of interest. Maybe it will be health parameters, maybe it will be yield, maybe it will be the financial performance, maybe it will be the HR performance or the emotional quotient of the person, and the two samples are independent. We apply the t-test, independent sample t-test over there. There we need to have a look at some of the assumptions. One is the independence assumption, that is most essential. Then we need to have the normality within each group. For one sample t-test, we need to have the the normality condition should be satisfied for all of the observations. But for the independent sample t-test, if we have the observations for males and females, there should be the normality should exist for the male participant scores, and again for the female participant scores separately, right? Another assumption which relates to this particular test is the homogeneity of variance. Homogeneity of variance means that is, there is no significant difference in the variances of the observations of the first group as compared to the observations of the second group, which is being considered over there. And again, there should not be very little responses in each group. In the treatment groups, you should try that there should be equal number of cases or number of items, and then that should be at least more than 6 in each group. For paired sample t-test, as I told you, the respondents are the same, or the cases are the same, and the treatment which we are giving, or the condition which we are testing, is before and after. That is in the sense, before the performance of the average performance of the companies, before the CSR clause in India, or average of the companies, 5-year average of the companies, of the same companies, after the introduction of the 5-year clause, or in the case of the experiments, that is the score before giving the treatment and after giving the treatment. As I told you, that is just satisfying the hypothesis, or that is accepting or rejecting the hypothesis, does not make it enough or ample or substantive for the arena of research. It is always good to have the effect size. That is, what replications it can be made, or for it is also important from the point of view of having the meta-analysis in future, that you should always report the effect size. Some of the softwares nowadays are able to give this effect size by themselves. They calculate the effect size and give it to you. Likewise, Jamovi is there, R is there. But some of the softwares, they do not give the effect size, and you should actually calculate it by the traditional formulas and report it in your studies to increase the impact of your studies. The other test, that is the counterpart of the independent sample t-test, is the Mann-Whitney U-test. That if the condition of the normality is not satisfied, if there are not equal items or cases in each group, then we go in for the Mann-Whitney U-test for comparison of two independent samples. Even if the data is on the ordinal scale, that is, you got the data from the two groups in the form of ranking or rating for a particular context. That is, actually, you did not get the score, but you got the rankings in that context. Then instead of t-test, we go in for the Mann-Whitney U-test. Again, the most important assumption, as in the case of independent sample t-test here, is that is independent random sample should be there. It should at least be measured on ordinal scale, and the underlying dimensions of the dependent variable must be continuous in nature. Again, the formula for the effect size is given. You can either calculate it, because this is Z parameter, that is standard normal variate value, Z value you get in when you apply this test, and then you can calculate the effect size, that how it can be replicated for the population, how good the results are, what is the level of significance of the differences which you are reporting, whether there is a significant difference or not. For the counterpart of the paired sample t-test, for the non-parametric test, if the conditions are not satisfied, we have the Wilcoxon signed rank test for two related samples. That is, the respondents are the same. Scale of measurement within each pair must be at least ordinal, and differences in the score also constitute an ordinal scale. Likewise, you got the rating about the company or about a particular plan from the respondents before explaining the benefits of that plan, and then you got the responses from the individuals in form of again on the ordinal scale, after explaining them the benefits of the policy, or after explaining them or giving them some sort of treatment. So there you can apply for the Wilcoxon signed rank test. That is, else if it is nominal, that is yes, no before and yes, no after, you can go in for the Manoeuvre test. And even though if the usually it does not happen, but in the case of medical sciences, it may happen that the medical treatment being given is so crucial, like for the case of the corona patients. So it can be, the sample can be around 6 or less, because it should be sort of case study. Then you can apply the sign test over there. Then again, this is the formula for the effect size we should always report. Now we extend from the family of the two levels, that is independent variable, two categories only, to the family of the test, where we have the independent variable still as categorical, but we have multiple levels over there. So there we can apply for one-way analysis of Anova. One-way analysis of Anova is applied where we have one independent variable. It has more than two levels, and we have a dependent variable which is on the continuous scale or the metric actual performance numbers, maybe percentage score of the students or the numbers actually. And we want to compare the performance across the various groups, whether there is a significant difference or not, whether one group is which group is performing better than the other, and if there exist the significant differences between the groups, is it whether the first group is significantly different from the second, or the second group is significantly different from first and third, because here the differences would mean that we have to do some post hoc analysis, in the sense that which group is performing, which group is significantly different from the other, or all the groups which are being compared, 3 or 4 groups, are altogether different groups. Usually, when we talk about treatments, one group we take as the control group. That is for the planned comparison. In case of planned comparisons, we take a control group where no treatment had been given, and we consider various other groups where the treatments have been given. Although the social scientists have been using this one-way analysis of variance, but it is always better to use the regression in that context, because here it is not of the experiment, it is basically more of the survey. So when you are working with the survey, it should more be of the regression analysis rather than the analysis of variance. And again, when we apply one-way analysis of variance, we need to control the family error rate, because here, once we have applied the test, we come to know that they are significantly different. Which group is significantly different from the other? If we make 2-by-2 comparisons, in such a case, it may give rise to the family-wise error. So how that should be dealt with, we'll just be shortly be talking about the basically the post hoc tests which are available, and in which context, which post hoc test must be applied for the Anova context. And it is very, very nice to know, because at this level, similar context, this Anova test is so important that even after performing Manoeuvre, if we want to perform this post hoc test, that is often done through Anova itself, because here it actually tries to compare group by group, 2 groups at a time. It has such sort of post hoc test available, right? What are the assumptions? Again, normality is the major assumption. Normality assumption here states that there should be normality within the groups which are being compared. If there are 3 groups, then the observations which we have taken, they should be normally distributed. There should not be outliers. They should be within an appropriate limit, so that mean plus minus 3 SD. That is, most of the observations should lie between this. Or you can actually perform the normality test, which I have already told, that is Kruskal-Wallis H test or the Shapiro-Wilk test. But again, that has to be normality, not the normality of whole of the group, but you have to take care of normality within each group being compared. Then there should be homogeneity of variance. Homogeneity of variance here means that the groups being compared should actually be comparable. The variance of one group should not differ much from the variance of any other group. Maybe likewise, if we are trying to compare the performance of 3 banks or the number of customers with 3 banks, 3 types of banks, public banks, private banks, foreign banks. So what does it mean over there? That maybe the private banks are not performing so well. So although the observations or the readings are less, the performance is low, but the spread of the performance should not be so much that the variance rate is higher than, or it is not comparable to the variance in the other group. Often this is also done through box plot diagrams, but we have different tests available. That is Leibniz test in case of Anova. In case of Manoeuvre, we'll talk about again Leibniz test, not Leibniz test, but box M test is there. So there are different tests available for that. And again, as I told you earlier, it is more important to design a study well if we want to apply a particular statistical test of interest. So in that case, if we have equal number of respondents or equal number of cases in the groups being compared, then this assumption of normality and this assumption of homogeneity of variance, even if violated, you can still go in for these tests because there are alternatives available in these particular tests, which are extensions to the Anova. You can always apply over there. Likewise, instead of looking at the F ratio, you can go in for the Brown-Forsyth test. So these are the various tests which are inbuilt tests in many of the softwares, and you can study in extension to that, right? So what if the assumptions are not satisfied. Okay, Ahmed sir has put up a question just now that when we apply one tail test and how to decide whether right tail or left tail. Sir, actually that is based on the review of literature, that whether we are going in for the right tail test or the left tail test, as I told you in the beginning, that the directional hypothesis. Okay, performance of bank over 10 years where T tests can be used. Please clear my doubt. I think such type of doubt may be taken up later, but at least at this point, I'll try to tell you that in such studies, because time variant is also included over there, performance of bank over 10 years, there you should use panel data regression rather than going in for the hypothesis test. And as I have told you that these tests which I am talking as of now are, that is Anova, is more relevant to the controlled experiments rather than going in for the survey based. So this would be a sort of survey test, Rohit sir, as you asked, that is study of performance of bank over 10 years. So that should be done in the case of the time series analysis, or in the panel data analysis will be coming to soon. Then dependent variables should at least be an interval scale. That is, I already told you that it should be metric. Then it is preferable to have sample size equal. I have already told. I have little time and I want to cover as much as I can. Why normality is important? If everyone going to click over neutral in interval scale, then what is the use of statistics? Normalities is important because if everybody is going to click on the neutral scale, that means you have not well designed your study. That means there is some problem with the scale which you have developed or the respondents which you have chosen for the study. In that sense, normality is important because it has to do much with the homogeneous data, because actually in the population, every kind of people exist, every kind of individual exists, which may have very low score, which most of the phenomena. Actually, it is with most of the phenomena. But normality condition, if you have a large sample set, then there we apply theory of central theorem, that is law of large numbers, and then theory of central central theorem, where it means that if you have a large data set, many of the people you are studying, then even if the normality condition is not satisfied or the data is skewed, you can still apply this test. I think I have cleared it out in that sense. Ranges between 30 to 500. What is your take on this? Sample size is again a topic of discussion and deliberation for so long. It actually depends on the population, that what sample size can be considered large and what sample size can be considered small. For likewise, catering to your question, Dr. Ghosia, as you have mentioned, a sample of 30 companies may be ample. A sample of 30 patients may be ample, but a sample of 500 consumers may not be ample, because when you are going to make the predictions for lakhs and lakhs of people, it is actually expected that you should have a larger sample. But while you are going in for the study of the companies and you are trying some treatment, then again a sample of 30 would be enough. There are various tests and various parameters available on which you can actually check that what should be the sample size. For example, if we want to compare the sales of 2 years of 100, again, sir, where time is also there and you have some observations across the companies, then Dr. Samir will be talking about. If you will allow me to move further, then only we'll be able to cater to these specific questions. So if you have some questions specific to the technique, please talk over, otherwise we'll be left over. We have a lot to discuss over here, right? Further, I was talking about Anova. I told you why it is a robust test, because even the violations of the assumptions can be worked out, and there are various other variants available in this test which can resolve the issues of homogeneity of variance. And apart from that, if you want to have the planned comparisons, or you have some like I told, that one group is better than the other, you have such assumptions, then you will apply different family of Anova test. And if you want to compare that you do not know which would be better, there is no directional hypothesis, then again you have different variant of Anova over there. So violations to assumption of independence are very crucial in this case. Otherwise, if group sizes are equal, you can easily go in for the t-test, you can easily go in for the Anova. And you have other tests also available, other parameters also available in this test. These are some of the post-hoc tests which are available. Choice of post-hoc test you can make for the Anova, and even for the case of Manoeuvre, if you're going in for the post-hoc through Anova, you can go in for this post-hoc test. That is the sense, if we have equal sample sizes, homogeneity of variance, we go in for these tests. That is Bonferroni, Tucky. These tests are all actually they have corrected the family-wise errors in context to the different conditions. Further, if we violate these conditions of normality, homogeneity of variance, and even we do not have the equal cases to compare for the case of Anova, then we can go in for the substitute for one-way Anova is the Kruskal-Wallis edge test, which is again calculated on the basis of the ranking or the orderly arrangement of the scores, which are the actual scores. And this is again working more on the median. So the conditions here should be, that is either the conditions of the the condition of the independent random sample, that is independent entry should be there. It should at least be on the ordinal scale. And usually Kruskal-Wallis edge test is used as a substitute of one-way Anova. There must be at least 5 cases in each of the sample. Then for the post-hoc test, if we have equal groups, then we can easily, if we do not have equal groups or the equal groups, usually we go in for the post-hoc tests which are available in Anova itself, or otherwise there is a manual procedure which can be taken over for the post-hoc of the groups being comparison. Because the question here is in Anova and Kruskal-Wallis edge test that the number of groups being compared are more.
So although the hypothesis states that there is a significant difference, but which two groups are significantly different? What is the direction of that difference can be seen through box plot, or otherwise to check whether these differences are significantly different between which groups. You need to perform certain post-hoc tests in that context. Now, talking about, as I had told you, that again, one-way repeated measure, where it is applied, where we have one independent variable, right? Two or more categorical related groups, that is the same group, different treatments, observations at different point in time, and one dependent variable, that is the respondents are the same. In one-way ANOVA, the groups given the treatment were different, and the major assumption was they should be individual independent cases, like different companies being considered over it there. But if we have the same cases, same individuals, same patients, and different tests, then as I told you, that one-way repeated measure ANOVA is used over there. And the points, basically 3 questions you have to take care. That is there a direct relationship between each pair of observation, that is before versus after scores of the same on the same subject, or sometimes it is assumed that on the same level if the subject and it is very important, that is the longitudinal nature of the study is maintained over there. So that is why again initially I told, when you are doing it through survey of the humans, then it should have greater number over there, right? So that even if someone drops out at the another level, you cannot substitute the same case by some other case. So the respondent is the same, or the company being studied is the same in that sense, right? Are the observations of the data points definitely not random? That is, they must not be randomly selected specimen of the same population, but they should be judicially selected over there. Do all observations have to have the same number of data points? Yes, that is, they should have equal number of data points over there if you want to apply the one-way repeated measure ANOVA. Now, the normality condition is the same as I explained for ANOVA, for t-test, that is group-wise normality should be there. And there is the condition of sparsity. Sparsity is again the extension of, if you say, that is homogeneity of variance, that is equality of variance of differences between levels of within subject factor. It does not apply if there are only 2 levels within subject factors, because there we will be actually we will not be able to apply this repeated measure ANOVA. The levels are more, then we apply this repeated measure ANOVA. That is, we do not apply if there are only 2 levels of within subject factors. There we will go in for the t-test, paired sample t-test, rather than repeated measure ANOVA, right? Now, this substitute for repeated measure ANOVA, if the condition of homogeneity of variance is not satisfied, normality is not satisfied, that is sparsity is not satisfied, or normality is not satisfied, then we can go in for the another ANOVA test, which is given by Friedman. It is used instead of Wilcoxon sign rank test, if you understand it clearly, and the alternative to repeated measure ANOVA, where assumptions are violated. Again, scale must at least be ordinal, and random sample of subjects may be asserted to different groups we are trying to compare. If again the data is metric, not normal, we apply Friedman ANOVA test. Otherwise, if we are working on ordinal scale, right, and several related samples, that is, we took the ranking before showing the brochure or explaining the context, and then we again took the perception in the form of rank or on the ordinal scale after showing the video clips or the awareness level of people initially, then awareness level in the sense highly aware, less aware, moderately aware in that sense, right, ordinal. And then after giving the first treatment, again the same 1, 2, 3, here it represents the position, and then again after that, after giving a different treatment, showing the video clips or tackling their queries, and then asking, so that we can actually make out that what works more for the same individuals, whether the brochures and the discussions or the video mode or the query session mode. So in that case, instead of Friedman ANOVA test, we apply Kendall's W, when we are looking at agreement between raters of common subjects or we are talking about the same individuals given the perception on rating scale in the form of ordinal scale at 3 different points in time. Cochrane Q is applied when we have dichotomous data. Likewise, we asked whether you want to purchase the product or not. This is again experimental study. You want to purchase the product or not? The person said no. Okay, further I told, okay, give me some time. We talked over, we showed some advertisements. Then yes or no. And further, after some point in time, if you are asking the same person whether you want to repeat the purchase or not, this is much talked about and much needed type of study nowadays, where they are saying that is action-oriented research is needed over there. That is, the experimental nature of the study is needed over there. So if you took the responses in the dichotomous form, then it will be Cochrane Q test. I hope you are able to understand the examples and the applicability which I am telling. Regarding the post hoc and the effect size, it is the same as now we compare. We have to control for the family-wise error. I have explained the technique here. It will take if I go in for the explaining each and every in the sense key how you have to perform the post hoc test, how you have to do it. But still, if you are comparing 3 groups, then the level of significance likewise, if it was 5%, so it will be gone down to 0.017. That is, you have to compare now the p-value to 0.017 rather than comparing it to 0.05. This is the Braun-Coroney correction which he had given if we have more than 2 groups. If we are going to compare 4 groups, it would be 0.05 dividing by 4. Whatever the value comes, now we have to compare the p-value for the test, probability value of the test with the actually the new calculated value rather than going for the initial level of significance which we had set, because in this case of multiple comparisons, right? And again, you should always calculate for the effect size. Now, if we talk about, we have data on the nominal format, right? And it is used to compare observed frequencies of an attribute with expected frequencies, that how many people fall in which category. That is, in the sense, we want to see the association between the high performers, whether it has something to do, if you see that high performers category over a class, whether what is the expected number which would fall in the high performers, low performers, moderate performers. We have the data in such sense. So there we have various population proportion, that in Delhi there are these many users, in Mumbai there are these many users, and so on. So if it is used to compare the observed frequencies of an attribute with expected frequencies, basically, right? Whether there is a significant difference in the users in different metro cities, or the users and non-users across different metro cities, then we will go in for the chi-square test for goodness of fit. It is more of the test for the association also, and for the test for the significant differences also, because here the significant differences, if they come out to be, that would mean that the city, metro city or the city has something to do, has some relationship with the usability of the product, users and the non-users. So the assumptions are lighter when we come to the non-parametric versions of the test. That is, there should be randomness of the sample. That is, they should not be from the same locality or the demographic variables. On that basis, there should be randomness in the sample. Then they should have independent entries, because one who belongs to Delhi won't belong to Madras, right? Chennai, right? So independence of the entries should be maintained over there. Likewise, in the case of independent sample t-test, or we talked about in the case of like Manoeuvre U-test. So again, here the entries should be independent. Then expected frequency should be at least 10. And these expected frequencies actually depend upon the observed frequencies. So class of people falling in one category, among each category, again, they should be more and more. So when will this happen? There is a word of caution whenever we apply non-parametric sample sets, so that we can have larger variability of the responses. As one of the participants just now asked, that if everybody marks it on neutral, so larger the sample set, lesser will be such problem, because more and more people will be having diversity of their diversity of their responses. So expected frequency should be at least 10 in 2 by 2 table, else in other tables it should be at least 5 if this assumption is violated, because expected frequency in chi-square test again depends on the observed frequencies. So if we are considering the high performance in private banks, low performers in private banks, the data we collect or the criteria we set, that should have ample number of observations in each category. If it is not so, we need to either club up the categories which we have created, because here the dependent variable is also non-metric and the independent variable is also non-metric. So if there are more than 2 categories, that is why in this beginning I told you should have more and more of levels. If you have greater levels, you can submerge 2 levels to 1 level, right? You can club up the levels. So if the assumption is violated, instead of going in for the direct chi-square value, we go in for the Fisher's exact test over there, which is the another version of inbuilt version of the chi-square test itself, right? Then we can have chi-square test for independence between 2 variables. Again, it is the similar as discussed in the previous one, that is various population proportion, number of people falling in each category, or it may be 2 attributes, relationship between 2 attributes, as I told you earlier also. And then again, the effect size, that what is the degree of association if measured in number. So we calculate the contingency coefficient over there if we have rows equal to columns. Rows equal to columns here means that if we are getting 2 by 2 tables, that is in the sense that we are comparing, for example, public and private banks, and here the higher number of customers and lower number of customers, that is 2 categories, both the sides. If we have more categories on either side, that is, it is not balanced, then we go in more for the Kramer V. That is 3 by 3 table. It will be again contingency coefficient. If it is 3 by 4, 4 by 3 sort of attribute, that is level of the considerations under each of the attributes which are being considered for the association, for the independence between the 2 variables, then we'll go in for Kramer V to calculate the basically the effect size or the degree of association. We can have again in the chi-square test, it is very important test when we want to understand even the structure equation, because there again the distribution is chi-square distribution, which is used for the goodness of fit, right? So it is often used as goodness of fit, as I told you earlier also. So in that context, it is very important test. And we can have multi-layer, that is multiple variables. For the multivariate analysis also, again, we can have chi-square in that context. That is, we can have control groups, add layers, and cross-tab comparisons, right? It can also be used for bivariate. It can also be used for the multivariate. In that context, if we want to control the effect of, if we want to see the default rate, right? Default rate in the case of banking. And we want to study 2 variables that within each age group, which level of education is more associated with the default rate. Default rate has been measured in the form of yes and no. Then again, we have the age in the form of categories, income in the form of categories. Which test you can apply over there? You can apply chi-square test over there. That within each age group, whether there is a significant association between a particular this income level and default. Otherwise, it can be different also. That is, it can be within each income group, what is the major age group which is the default group. So when we have such kind of relationships to study, where we are considering more of the nominal data, there we go in for the chi-square test. This is again effect size. One-way and ANCOVA. One-way and ANCOVA we apply when it is used to test if there are 3 or more independent groups. Likewise, and they are significantly different from each other with regard to dependent variable, which is the continuous. And now we have one control variable also. This has to be continuous again. This is what we have measured through a scale. Likewise, this is performance. And then we have job satisfaction in the form of categories again over here. That is in the sense highly satisfied, moderately satisfied, less satisfied. So we have the categories over here. Whereas this is in the basis of experience. That is, we want to control the effect of experience, and we basically want to see the relationship between, is there any significant difference in the performance based on job satisfaction controlling the effect of experience. Then we go in for analysis of covariance, that these are the covariants, these are the confounding variables, we are controlling for that, and we are interested in the two interest variables, that is independent variable. Again, we have job satisfaction as a categorical variable and performance as a continuous variable. So there should be more than 5 values in each group, and preferably equal observations in each group, because again, this has all the assumptions in extension to Anova. That is why I said that it is always good to have the know-how of the basic test so that you can extend those to the further, right? I hope it is clear so far. The assumptions are, again, that is, it should be on the continuous scale. It should be normally distributed. This is with regard to the independent variable, because for the this is with regard to the dependent variable, continuous scale and normally distributed. This is with regard to performance. And with regard to the job satisfaction, the assumption is that we should have the random sample. That is, not only we should, it should not be biased that all the people from the same work area, and apart from that, we have biasness. We go in for taking more of the highly satisfied employees, not taking the less satisfied employees. So we should try to apply all sorts of people over there, and it should be random in that nature. Enough of the data within each of the category being compared, and similar spread across groups. That is, again, has to do with the homogeneity of variance. So these are the differences between Anova and Anova. If you have any confusions, Anova is examining the difference among the means of multiple groups of data for homogeneity, and Anova is a technique that remove the impact of one or more metric scale undesirable variable, that is the confounding variable. Because in this particular example, if you see, experience has a very important role for performance to play, and over the time when you gain experience, it would also may affect your job satisfaction somehow. But we are not considering the relationship between those two. We are basically considering, we are controlling the metric variable, and then we are removing its impact from independent variable before undertaking the research. Then both linear and non-linear models are used in Anova, whereas this has to do with linear model only. It includes categorical variable, categorical and interval variable. That is, in the sense, usually the ratio variable, like I talked about this particular example. Covariate is ignored in Anova, but it is a better version because covariate is considered in Anova. Why I'm teaching you Anova and Cova? To take you further for the major test, that is multivariate test. Because if you will be clear with these assumptions at the bivariate level, then only it will be easier for you to consider those in the multivariate analysis. Then attributes between group variation to treatment, and it divides between group variation into treatment and covariate. Within groups, and it divides within group variation into individual differences, and also control for the covariates in that sense, right? So this was the more of the story about the story of the differences between the two groups. But these differences actually seep down to relationships itself. Likewise, if you recall that we talked about t-test, we use this t-test also for checking whether in the regression models, if you have some know-how of the tests you apply, that whether a particular beta coefficient is significant to report or not. Where the assumption is, null hypothesis is, that is rho is equal to population correlation is equal to 0, and the alternate hypothesis is population correlation is not equal to 0. Here again, the same t-test can be extended to bivariate regression model, where we make use of dummy variables. So these categorical variables take the shape of dummy variables, that if it is male, you punch it numerically as 1, and if it is female, you punch it numerically as 0. And you would again have alpha in that sense, that is the constant value which the dependent variable would have, that is which is not being explained by the independent variable, that is if you're considering a single variable in your study. So therefore, the story has more to be of the multivariate characteristics, but still we have talked about these in the sense that the story of differences is also related to story of relationships. As I told that analytics is much to do with analysis also. So here, correlation and regression, in the sense, correlation, basically we are talking about relationships. We are talking about, again, I told you that the relationships can be in three forms. That is, that can be interdependent. So when we talk about the correlation, it is more of the interdependent. What is the relationship, movement of the movement or bidirectional relationship between the two variables being studied. And when we talk about regression, it is a unidirectional relationship that we are talking about. One is dependent and one is independent. For a dependent-independent relation to exist, there needs to be the judgment about bidirectional relationship, because only and only if there will be a bidirectional relationship, then only we can move in for the unidirectional relationship, that is the regression. So what are the different variants when talking about this correlation? What are the differences between non-parametric tests of relationship that you can, as I told you, as a post hoc test? For the chi-square test, we use phi coefficient. When we have dichotomous variables, in that sense, you had over there 2 by 2. There it was written phi coefficient. If you see, I'll just show you a quick visit back. So which means that if there is a significant difference in the two variables being compared, both on nominal, then what is the degree of difference? What is the degree of relationship will be determined by the phi coefficient. It can be measured by the phi coefficient over there. Therefore, I said that even all these relationships of the differences, test of differences seep down to test of relationship. We use point biserial measure of correlation when we have dichotomous by scaled variables. Likewise, if we want to see the association between gender and height is numeric, and gender is dichotomous over here. It can be in the form of, if you consider, right, likewise public and private banks, and the performance again. If you have found out significant differences, then what is the relationship, or what is the degree of relationship over there that exists, the differences that is measuring towards the effect size, basically. Spearman rho is used when we have ordinal by ordinal variables, or we have one is ordinal, the other may be ordinal, the other may be scaled, the other may be nominal without ties. If there are ties, then we move into general tau, that is ordinal by ordinal or scaled or nominal with ties. If we have scaled by scaled, with at least one variable skewed, as ma'am was asking, that one of the variable is skewed, that is people are responding towards one side. Summative score is going towards one side. Okay? The condition of normality is not being satisfied. So we cannot apply Karl-Pearson correlation over there. So it is better to use Spearman rho correlation, which works on the ranking of the numeric data actually. Likewise, we talked about that height in inches and average daily calorie intake, right? CSP expenditure and CFP, corporate financial performance, corporate social performance, corporate financial performance. And the data is one of the Spearman rho correlation. If it is skewed and it is one of the variables has ties also, then we will go in for the Kendall tau measure of correlation. So these are the various correlation types we will be using. Now this is the most important and the most robust one, and can be used only when variables are measured at least on interval scale, because we do not always work on the individual statements. These interval scales, Likert type ratio scale, these scales, 7 scale scales, 10 scale statements are meant for summative scores, to be working on the summative scores rather than the individual statements. Always remember that. So therefore, variables must be at least on interval scale, and preferably it should be on ratio scale. When you take the summative score, you take the average over there, it becomes on the continuous scale. For test statistic to be valid, the sampling distribution has to be normally distributed, approximately normally distributed. As I talked earlier, we always begin with scatter plot plot diagram. As I told in the case of the descriptive statistics, why it is important. It actually helps us to study whether the relationship is, what kind of relationship it is having, whether it has a relationship or not, whether there are outliers or not. If there are outliers, they need to be removed for the judicious decision making. Apart from that, if we can see that the reliability of car decreases as the age of car increases in this particular diagram, if it is shown in this way. So if it is plotted, it can easily be seen. Apart from that, it also helps us understand whether there is a linear relationship or not, because Carl-Pearson coefficient actually measures the linear relationships and not the non-linear relationships. So if Carl-Pearson coefficient correlation comes out to be 0, it never means there is no relationship. Then we will apply some other family of tests for the non-linear correlation, or will be predicting the relationship in that sense, and what kind of relationship exists. So it may be spurious if you are considering only two variables, because we are still talking about bivariate correlation. But as I told that in case of Anova and COVA, that we have started now talking about controlling the effects of the confounding variables, intervening variables. So there we have two variants of Carl-Pearson correlation further. That is, one is part correlation and one is partial correlation. Basically, the beta coefficient that you get in your regression equation is the partial correlation. Or if you want to see the relationship between two variables of interest, controlling the effect of the confounding variable. For example, if I want to see, for the agricultural people, if I want to see whether there is a significant relationship between the yield and irrigation, controlling for the temperature, right? So temperature is not, because that cannot be controlled, but it anyhow affects the yield. But now I want to see whether how much is irrigation related to the yield if we keep a control over the, we remove the effect of the temperature over there. Similarly, if I want to see, in the previous case also, I have performance measured on the actual scale, and it is in numbers. Then we have level of satisfaction also on numbers, and we want to control the effect of the experience in years. All these three are now the metric variables. So if we want to control the effect of the confounding variable, both on dependent variable and the independent variable, we apply partial correlation over there. But if we want to control only the effect of confounding variable on the independent variable, which is usually the criteria for the part correlation, that is semi-partial correlation. It does not control the influence of the confounding variable on the dependent variable, but only the independent variables. Okay. Thank you for the comments and the motivation. Thank you so much. Now, as I told you that actually the diagram shows whether there is a linear relationship or not. So there may be that there are some non-linear correlation. In that case, again, linear regression model will not apply. Non-linear model of regression will apply in that cases. How to decide the sample size if population size cannot be measured? Ma'am, there are various formulas available related to that. Cochrane Q is there. Past studies can be quoted in that context to decide over the sample size. So Poonam ma'am, I think I have answered to your query and some other queries also, because this question is coming time and again. No regression will be covered today itself. I'll elaborate the session a bit. Okay, so polynomial relationship, this is exponential and this is parabolic. So different type of regression will be applied. Bivariate regression, it is basically when we want to predict, we know the relationship exists in the form of dependent and the independent variable, and we have a single independent variable. So the beta coefficient, as I told you over here, is basically the partial correlation, right? Then these are the assumptions. This bivariate regression assumptions will carry forward for all the sorts of regression we are going to take up in the upcoming slides. That is, the error term should be normally distributed, which means that the differences between the actual and the predicted should be normally distributed. Error terms are uncorrelated. That means there is no autocorrelation. actually Girish sir and will take up the time series that again these assumptions will be tried and tested and explained better over there, and that will be covered over there. And again, the person, I think Dr. Jindagni will take over the panel data analysis. So again, that would be taken care of there. Now, bivariate nonlinear regression is basically in the format when we have, I showed you that we have nonlinear relationships, correlation, then we apply the nonlinear regression over there in the format of, or we apply the, we have transformable nonlinear model, that is log linear models over there, that we transform them into taking the logs, making it more of the normal, right? Now we are taking up with the most important part of the session, that is multivariate analysis. Multivariate, again, we'll talk it in two contexts, that is story of differences and story of relationships. So extension of Anova we have here is the Ankova, as I discussed earlier, Manoeuvre and Manoeuvre. That is when we have one continuous dependent variable and the independent variable, as I told, is discrete, and we are not considering the covariates. We have already discussed, we take over one-way Anova. We have also talked about that we have one continuous variable and one discrete variable, that is the categories, and there is some sort of covariate, we go in for one-way Anova. So extension to these, if we have one continuous variable and multiple independent variables, maybe I want to check the performance across cities and also across the different retail store setups, then it will be multiple. Maybe I want to give two sorts of treatments, as I told earlier, that is irrigation and temperature control also, and then I look for the germination in the crops or the different medications, that is psychotherapy and the medical therapy which is given in terms of medicines, and we have multiple independent variables with multiple categories inside one continuous variable, then we apply two-way Anova, or the extension to that, whether three-way Anova, four-way Anova, that is factorial Anova. And again, the assumptions are same: normality within each group, then homogeneity of variance across the groups, and similarly for the factorial Anova, it is basically the extension of one-way Anova. Now, where we use Manoeuvre, now we were dealing with only one dependent variable on continuous scale. If we want to talk about multiple dependent variable on continuous scales, likewise, then we go in for the family of Manoeuvre, that is one independent variable, no covariates, one-way Anova, one-way Manoeuvre, and if we want to control for the covariates, that is one-way Manoeuvre. Similarly, multiple both sides, multiple continuous scale dependent variable and multiple discrete variables, independent variables, then two-way Manoeuvre, three-way Manoeuvre, or if you want to control, then it will be various sorts of Manoeuvre. So these are the assumptions. We have already talked at length, that is linear relation should be there among all pairs, equality of error, variance and covariances, then normally distributed errors, which I had just now told you in the case of regression, because now everything is moving towards regression. One-way Manoeuvre, look at some examples I have put in over here. Likewise, if we want to study the case of, that is dependent variable are two. That is how successful a person is. I judged it through the test score and the annual income. If you want to have some quality parameters measured in latent and summative scores, and then we want to have actual numbers performance, that is the ranking of the companies, okay? That is perception toward the company or the sales of the companies over here and the income over here, right? And the independent variables are again categorical. So we can have one-way Manoeuvre. Similarly, next example is, I have quoted for the two-way Manoeuvre. That is now we have some other factor also here. That is independent variables have now become, this is again categorical, this is again categorical, but dependent variable, we have both of the dependent variables as the metric variables. Menkova, then one is the variable of interest, but the other is the variable or as the confounding variable, the effect of which we want to control. From the side of education, if we say, that is test score and annual income, that is the success of a person over the lifetime, and level of education, what it has to do if we control for the number of hours spent on study, right? Now, further taking the journey to story of relationships, that is multivariate correlation and regression. The multivariate analysis actually means that it should be multiple in real context. That is, the variables should also be multiple, which we are investigating, and they may be random and related in such a way that their different effects cannot be meaningfully interpreted. There is more of interdependence over there rather than dependence. Although there are multivariate, the multivariate analysis can broadly be classified into two types of relationships, that is dependence methods and interdependence methods, where we have one dependent variable and several independent variables, or it can be in the form of, that is, whether the independence methods for the metric variables or for the non-metric variables, or where we have both kinds of relationships under study, that is metric and non-metric. Same variables are acting as endogenous, exogenous variables, that is independent variables and dependent variables, and we have complex relationships to study. So starting with the simplest of the relationships, where we want to measure the degree of relationship among variables, we have already talked about bivariate. Extension to that is, we have one dependent variable, although as I told in correlation, we do not have we usually talk about the interdependence, but in some terms, it is actually, the yield cannot influence irrigation. It is the irrigation which will influence the yield. So logically speaking, where we can make out that one is the dependent variable, and we want to see the effect of multiple continuous variables, then we use the multiple correlation over there. Even the R square that you basically get at the end of the regression models is basically the multiple R square. If we have many covariates, we can use stepwise regression over there, in the sense, stepwise regression by the computer itself, that is which variable is most important depending upon the beta coefficient, or we can input it as backward or forward method, or we can input it step by step, what we feel, we as a researcher know that this should be the most important variable, this should be the lesser important variable. So in that sense, we can use the sequential multiple R over there, that is Carl-Pearson multiple correlation over there. Then multiple continuous and multiple continuous independent variables, it is canonical R, in that sense that it helps to analyze correlation between two data sets by either, what it will do, it is more like factor analysis. If most of the participants, they have often heard of this, what it does, we have several variables here and several variables here, we want to see the relationship. What it would do, that instead of seeing the relationship of x1 with y1, y2, y3, y4, then x1 with y1, y2, y3, y4, and so many relationships, to seep down to the calculations, it will club up these similar variables or the dimensions which have been used. So focusing on a dependence relationship and model the two data sets in a regression-like manner, data set y as a function of data set x, there we use it, or it helps us to analyze focusing on the exploration of the relationships between the two data sets without stating any data set as dependent or the independent variables. What it will do, it will make pairs over here, which are highly correlated variables. It will put in one canonical variate. Similarly, on the other side, which are more similar, we'll put on the other canonical variate. And if the other variables which are not highly correlated with these two variables, it will club up it into different canonical variate. And then it will find out multiple canonical correlations between these variables. So when we have basically the multiple dependent variable and multiple independent variables, both on continuous, we go in for canonical R, that is canonical correlation. Now, when we have dependent variable as continuous and independent variable as multiple, but in the sense that is discrete. So it is again in the format of chi-square test. It will again be in the format of multi-way frequency analysis, chi-square test, or the log linear analysis. We'll talk about later just now in the later slides. So starting with this, where to use which type of regression model, and we will fastly take the glimpse of all because we are running out of time. I have told you earlier also. That is, I wish to put so much within these 2 hours. Please bear if you are interested. So if we have continuous independent variable or mixed, that is continuous and categorical independent variables, the categorical independent variables are often changed into dummy variables. That is putting them existing or non-existing of the attribute as 1, 0. So if we have 3 categories, we have 2 dummy variables over there. And the third one is the base category. We can have all the categorical variables behave as the continuous variable with the values 1 and 0. If we have the continuous dependent variable, continuous means that can move into frictions, whereas count dependent variable means that is discrete dependent variable. So if we have actual numbers, continuous, that is in decimals also. This is not in decimals, that is discrete. We use, that is simple OLS regression, ordinary least square regression. If we have binary dependent variable, now we are walking towards that if we have categorical dependent variables, whereas continuous independent variables, we go in for logistic regression. There are various variants to it, logistic regression, that is binary, multinomial if we have multiple categories. But if we have categorical variables and they can be ordered, likewise, heavy users, medium users, light users. Or if you talk about high performers, moderate performers, low performers, that is no intention, some intention, very much intended to purchase, and they will purchase for sure. So we have the interval scale data maybe for the ordered categorical dependent variable, and the independent variable is continuous. We have ordinal logistic regression over there. Similarly, if we have continuous dependent variable and binary or categorical independent variable, we have already talked about, that is Anova. Or again, we can change it into the what I said, that the dummy variables, and we can use the this sort of OLS regression over there. But if it is in the form of treatment, that is controlled experiment, it should be Anova. But if it is on the basis of already collected data, that is a phenomenon that exists, then we can apply it is preferable to use regression over there. Similarly, here, if we have binary dependent variable and binary or categorical independent variable, we use, that is, as I told previously in this slide, I had mentioned that we have multi-way frequency analysis. So this is sort of the relationship I was talking about. We can use log linear models because this is logit and probit models. I'll just not shortly talking about, because here the probability of happening, not happening, or falling in a particular category is converted into a log function. So there we, instead of having 1 or 0, 1, 2, 3 numbers in that sort, we will have some values for the same. So there we use log linear models. A quick refresh, multiple linear regression, which is the extension of the bivariate regression. Again, the similar assumptions apply. Error term should be normally distributed. Means, again, if we have large sample set, this is again the beauty. You can still go in for multiple linear regression. As ma'am was saying, that many of the people have responded in the similar manner, but it should not be too skewed of the data, or the error term should be approximately normally distributed, not too much of skewed. Then we can again go in for multiple linear regression. So for each fixed value of x, the distribution of y is normal, right? The means of all these normal distributions, these are the assumptions which has to be satisfied of y given x lie on straight line. That is, there is a linear relationship in that. For non-linear, again, and again, this will be seen through what? That I told you, that the descriptive statistics, basically the graph you will draw for the dependent and the independent variables separate, right? So every relationship, this x is to y could be plotted more in the straight line format. That should be linear. Mean of error term should be 0. This is that is homoscedasticity. Variance of the error term should be constant. Then only it will be the line of best fit, because variance does not depend on the values assumed by x or some other confounding variable which you have not considered in the regression equation. Error terms are uncorrelated. That is again otherwise it means that the sample is not random. There is again In the cross-sectional data, likewise, you were talking about if we study the companies at the same moment of time, many of the companies, and we want to find out the relationship between the variables of interest, then it is lesser are the chances that error terms will be correlated. But Girish sir will discuss. Then in time series, there is the problem of serial autocorrelation, that the error terms are correlated and what should be done in that case. Then the most important assumption over here is, because there we had only a single variable, the regressors are independent among themselves. That means there should be no multiplicarity. If it exists, then instead of using multiple linear regression, it is better to use the SEM modeling, that is simultaneous equation modeling, in the format of structure equation modeling, because even the independent variables are not able to explain the dependent variable individually. There is some relationship that exists between the independent variables. Either they should be combined to make a single robust independent variable, or we should go in for the structure equation modeling, which is the higher form of regression. Everything in statistics seeps down to regression. Therefore, regression is called the queen of the parametric tests. And similarly, for the non-parametric test, everything seeps down to chi-square. Therefore, you can find chi-square so many places. Even in the structure equation modeling, the model fit is usually tested through adjusted chi-square, right? So, because that is known as the, you can use it exhaustively, it is known as the king of the non-parametric test. Now, in case of multiple non-linear regression, there are two popular types. Don't worry, if it is not linear, everything needs not to fit into straight line in life. You can use polynomial models. Polynomial models is, that is models involving one or more predictor variables, which include higher order terms, such as in the form of raised to power or the combination multiplication of the two. As I told that you can combine the variables. You can also multiply the variables and form an individual variable in the previous case also. That is multiple linear regression. But if they exist in this format, you can non-linear regression, you can go in for the polynomial models. And models that are not non-linear in the parameters, models in which the partial derivatives of y with respect to predicted variables involve the unknown parameters, you have a different family for that. And one family I have already discussed, that is in the bivariate regression itself, transformable. That is in the sense that you can transform the variables, take the logs of the variables, take the reciprocals of the variables, take the square root of the variables, take the squares of the variables. Multiple treatments are available over there, so that maybe on transforming the variables, taking the logs on these things, the relationship gets into a linear format, because it has the easier predictability as compared to the non-linear regression, because the R square again the explained variance here is not robust as in the case of multiple linear regression, and it is more robust in that case rather than in the multiple non-linear regression. There are certain references I have put in under these slides. If you want to study for these non-linear, I must say he is a genius in this, that is time series regression. When in the case of multiple linear regression models, likewise, sir was asking that we have data for the companies over so many years, same company data, I'm still talking of same company data, same economy data over the period of time. That is, time itself is a major influencer, or we want to control the effect of these situations which have occurred over the time, over the years. We want to see that effect also in the economy. Then we will use the time series regression. And it has again the similar assumptions as we talked earlier. It has additional assumption of stationarity due to paucity of time and not taking it as of now. Girish sir will be dealing it with very well. Then again, within the time series models, we have two types of models, that is time domain examples and frequency domain examples. Time domain approach or the time domain models, they predict future values as a function of past values and the present values. That is analysis, which forms the basis of analytics. Whereas frequency domain models are based on the idea that time series can be represented as a function of time using sines and cosines. So these representations are basically known as Fourier representation. So you will have to see that if there is autocorrelation problem, which kind of model you will be using over there, and what is the level of that stationarity, non-stationarity. So sir will be telling you about giving the glimpse of these models, ARMA, ARIMA, BAR, GARCH. Maybe you can learn the basics and then you can take it to future. Then they can be univariate model examples in time series and multivariate model examples, that is GARCH, SARIMA, univariate unit root test. These are all univariate model examples, whereas multivariate model examples are, that is, we have multiple variables in that sense, that is vector autoregressive models, vector error correction. Sir will be talking in detail about all these. Then non-linear time series is again over there. So we should identify for the structural breaks. If there are non-linear time series regression, then these are periodic studies, that is before and after introduction of some norms or some historic events or change in policy measures actually comes. That causes the non-linear time series regression. We should try to find out those reasons, and then special models are used in that case when we have non-linear time series regression. Now the query that had been raised by Rahul sir, I suppose, that is panel data regression. This is the most beautiful regression or the most predictive ability regression we can have, because here we are trying to see the effect of individual companies, what are the countries, what are the differences, individual group differences also. And we are also trying to capture the differences on the basis of time, that is the confounding variables which are dependent upon the time value. So there we use panel data regression, and it is the best kind of regression if you can apply. Action-oriented researchers are now focuses on the panel data regression, like it should be longitudinal studies, not the same respondents, even different respondents, different time periods, controlling the time periods effect also, controlling the effect of the respondents also from the various countries and so far. This is panel data regression. Like time series data, panel data, observations collected at a regular frequency chronologically. Like cross-sectional data, panel data contains observations across a collection of individuals. So it has all the beauty of the cross-section, that is the multiple regression, which we talked about, and also the time series. So there are various, again, types of this, that is homogeneous, where we consider that there is no time effect and no individual difference effects, or the group-wise differences are enough to report or study over there. There we use pooled panel data, where we see that there are some differences with regard to time effect or with regard to the corporates we are studying or the groups we are studying, countries we are studying. And either both of them have some effect or one of them have some effect. We're going for the heterogeneous models in the sense of fixed effects. And if we see not only the beta coefficients are significantly different in this context with regard to the companies, with regard to the time variant, but also the alpha, that is the constant, differs across the various individuals or various time zones, then we go in for the random effect or the dynamic models are available over there, which is the highest form of panel data regression. And the big data analysis has more to do with these dynamic models. Now there are some other important types of regression also. I have already talked about log linear regression, that is for the continuous variables. You can, the difference between the log linear and linear models is in fact that log linear model dependent variables are product instead of a sum of independent variables. So you can take the logs of the values, and maybe the linear, non-linear models can be converted into log linear regression models. For categorical variables, again, we have Poisson multinomial, product multinomial regression over here is used. I discussed in the beginning also. That is when we want to study the association of the categorical or continuous independent variables, that is mixed variables, and one dichotomous dependent variable, maybe purchaser, non-purchaser, pass the criteria, fail the criteria, above the given criteria, below the given criteria. So we have the dichotomous dependent variable, that is only two categories, dependent variable and multiple independent variables. They may be independent, they may be categorical. There we use logistic regression. And logistic regression and probability regression, they do not have much of the difference, but only the difference exists that they have a different link function. They differ on the link function because here natural log of the odds is used for the dependent variable, and here the inverse standard normal distribution of the probability is used, which is the inbuilt criteria. You do not need to worry about that. So logistic and probability regression are used interchangeably, but most of the times logistic regression is due to its interpretation, due to its post analysis. Likewise, in the case of in every regression model, not only the model should be fit, but we should also be able to declare the R square. That is again the effect size. That is how then multinomial regression. This is again the extension of logistic regression, where dependent and independent variables, more of the dependent variables and more of the independent variables. Ordinal regression, where the dependent variable is of ordinal nature and other things remain the same as in the logistic regression analysis. The criteria of calculations are different. Otherwise, it is most of the same as logistic regression analysis. Now, some of the popular techniques in the format of regression we have, and usually it is used in the case of the marketing. But again, in the field of sciences, it can deal with the clientele in the sense, because we talk about the interdisciplinary studies. Dilip sir again talked about this in this session on the very first day. If you want to see that what attributes are most important when the patients come to an organization, or for the agricultural people or biomedical people, it can be again in the format what attributes are being considered by the supply end or the demand end. There, if we want to talk about the attributes, it helps researchers estimate the trade-offs that respondents or consumers make on psychological level when they evaluate numerous attributes simultaneously. Then we go in for the conjoint analysis. When we want to see our marketing positioning, that is how far off we stand from the other brands or the combination of the services which are being offered by us, then we go in for the linear discriminant analysis or the multivariate discriminant analysis. Cluster analysis is basically the segmentation technique. Here, in these two techniques, we are talking about attributes. Here, we are talking about cases. Likewise, I talked about defaulters, non-defaulters. If we have complex data available with regard to that, instead of going in for the chi-square, the better technique would be the cluster analysis. That is, it tries to identify homogeneous groups or cases. What kind of people do what, or what treatment should be given to the different type of people. So there, that can the individuals can be clustered. Here, the attributes are clustered. That is discriminant analysis. So conjoint analysis helps us in determining the package of services which will be offered. Discriminant analysis wants to evaluate that how we are performing on different attributes as compared to the other companies. And this is again, this all works on the criteria of the regression models. The objective of discriminant analysis is to develop discriminant functions that are nothing but the linear combination of independent variables that will discriminate between the categories of dependent variable in a perfect manner. Now here, again, that is, we are trying to form the combination or the which variables are more important while making the choices. Choice is the dependent variable and which attributes are more important. So that is the conjoint analysis. Then we have multidimensional scaling. It is again much similar to the discriminant analysis. We have metric multidimensional scaling. That is, it is also known as principal coordinate analysis. It is used, that is the numerical distances are covered over there. It is often used for perceptual mapping. That is regarding issues and objects, how the people are actually feeling. And then if we categorize on that basis, then it becomes the format, takes the format of the discriminant analysis. Non-metric multidimensional scaling, it deals with non-numerical distances between the items. That is, the exact distance cannot be measured. It is not in the numbers. That is parametric and non-parametric version again. So no measurement error again. Individual differential scaling, it applies when you have multiple different estimates of distances between items. And again, the mapping is done, basically allow people to have different perceptions of reality. Here, different perceptions of reality is not taken care of because it takes into pattern that it takes that simply the numerical distances which are predetermined. So these are some of the techniques which are related to multidimensional scaling. Group membership, we have already talked about. These were the techniques how and where we use. Due to paucity of time, again, it is 4:16 already, so I'm rushing a bit. But you can always take your queries in the later query, 15 minutes for the query. We have structure equation modeling because this is the highest form where we talk that there are interdependent relationships which we want to study. So in that, firstly, we have factor analysis. Likewise, the variables like in canonical R, basically, nobody is so known about this, but canonical R is basically the basis of this factor analysis, much to the same. That factor analysis is basically again journal linear model that we have measured certain variables. These variables are related to a particular latent phenomenon, that is satisfaction. It is measured through certain statements, and the responses have been taken, and which statements basically are relevant to satisfaction, which statements are basically related to which attribute. If we have an idea priorly, we go in for the confirmatory factor analysis. Otherwise, if we do not know which statement should go where for the dimension reduction, we go in for the exploratory factor analysis. So there are various methodologies to doing both of these, exploratory factor analysis and confirmatory factor analysis. Exploratory, it is most common factor analysis when we do not have the prior scale basically while developing such skills, and confirmatory when we know about the relations, we have some theoretical backgrounds, and then we are using those variables in our context, and whether we want to confirm the statements which had been taken by the previous researcher, actually in our context, whether they meet out our criteria, then we go in for the confirmatory factor analysis. Why to use SEM? I have already actually touched this area, that it is combination of multiple regression and factor analysis. Multiple regression where we have multi-connectivity issues. There are interdependence in the independent variables, right? And factor analysis because we want to reduce the number of independent variables to some particular factors. So there we use structure equation modeling. Actually, regression works more on the observed variables, whereas in social sciences we talk about the latent variables, phenomena. So it can deal both with the observed and the unobserved variables. Then it can have the assessment of measurement error, which is better assessment of measurement error as compared to the regression analysis. We can also form scales over there. We cannot use regression for forming the scales, developing new scales and theories. Then we have many complex models use SEM. It supports multiplicity. It supports the testing of mediation, moderation effects. Otherwise, we will have to put n number of linear regression models, multiple regression models to get for that. But while we are doing SEM has inbuilt all those multiple regression models doing simultaneously. And then, please, more details of factor analysis in medicine. Okay, factor analysis in medicine, in that sense, physical, on mental well-being, and on social well-being or emotional well-being. You have different criteria in that context, right, Nasir sir? And then in that context, if you wish to develop certain skills to measure these, or you wish to sieve down various observed measures you have and you want to collect them, whether they can be collected to form a particular factor or a particular phenomenon that you want to explain in your study, there you can use the factor analysis. Please, more details about factor analysis related to banking sector. Again, banking sector, sir. Banking sector is an arena related to finance. So where we talk about behavioral finance studies, likewise, we want to deal with the perceptions of the people, perception of the consumers, or we can talk about the satisfaction level of the consumers. You can easily use factor analysis over there, right? Then going further ahead, there is a row about this, that which type of SEM should we apply? That is, what is the difference between applying SEM through AMOS and what is the purpose of a based SEM, or what is popularly nowadays known as PLSM in the market, right? Covariance-based SEM, there are some limitations that it cannot be majorly used for making new scales, that is the formative scales. Whereas it can be used for the reflective scales, for which we know that statements already exist. And we are considering that these statements will be explaining a particular phenomenon or a particular factor, and we are allowing for the errors over there. But here we are saying that even those errors which exist over here, that will act as the components, and the proportion it explains is majorly taken care of, and errors are ignored. In that sense, there we use the variance-based SEM or the PLS SEM. So when we have theory background, it is better to go in for the AMOS or the covariance-based SEM, which it applies. And when we do not have a theory and we want to check some new models, develop some new models, you can obviously do it through covariance-based SEM. But if it is a complex model, we can go in for the variance-based SEM. So these are some of the differences. There is lesser of time so that it can be discussed at length. And even the robust measures, like I talked about R square in the case of regression, here the reliability measures are also different. It's the Cronbach alpha, whereas it's points F square here, that which variable is most important. Predictive ability, again, that is measured through different criteria, that is Q square is there, predictive relevance, whereas here we have overall model fit, GFI, CFI indices. We do not have GFI, CFI indices here, the other things. But main criteria, that is the discussion has to be centered around. I'm not here to teach the statistical technique, but where to apply what, which statistical test. So if the assumptions, the analytical hierarchy process, it works on the fuzzy logic, computer logic, because now AI is coming into, artificial intelligence is now coming into, our computers know-how is coming into the field of statistics. So these are two, basically the mergers of fuzzy analytical hierarchy process and neural networks is the combination of these two. Like in the sense that here also there is a fuzzy logic dependent upon the computer programming and computer numbers, randomly generated numbers. And actually Zadeh firstly proposed this fuzzy AHP, that is analytical hierarchical process, where we can term, although we had been doing it through regression models itself, where we can term, although we had been doing it through regression models itself, which variable is more important, which attribute is less important, through conjoint analysis. But new fad or new technique which is in is the fuzzy logic. That is, it under uncertain situations, it helps in prioritizing the factors, attributes, projects, multiple decision criteria. So there we use fuzzy analytical hierarchy process. Meta-analysis, very important technique. Those who are interested in the domain-based theory development or the SLR reviews, systematic literature review, meta-analysis, that is in the sense that if we have several beta coefficients, several correlations, several effect sizes related to different populations, so we can again studies done in different countries to be predicted for underdeveloped countries. What is the relationship two variables? For the underdeveloped countries, what is the relationship between two variables? We want to generalize these studies. So there we can go in for the meta-analysis. It was firstly defined by Glass in 1976. That is basically, you can say means of means, variances of variance. That is taking out a combined measure for across the samples, an average of all, right? So it is usually important to have effect size, sample size, reliability measured apart from the statistical measures, which are of interest to us. Granular causality, maybe Sir will touch it in the sense that sometimes, that is, we say that interdependence relationship, what factor affects what. That is, it is basically the previous year's corporate social performance, which brings in the financial performance here, or the treatment given in the previous experiment, which affects the future experiment. So which variables of past can affect, or there is interdependence, but which direction of relationship is more important or more rigorous can be determined through granular causality. Then we have economics. Mostly econometric people are working on neural networks nowadays, artificial neural network or simulated neural networks. That is basically, again, it is just like the neurons, how the neurons of the brain work for taking a decision. So here we have many input variables, many mediating, moderating variables, to put it in simple terms, and many output variables. So there we go in for the neural networks or the artificial neural networks is the new technique in the statistical area. So this was all from my side. And some of you were asking for the email ID, the slides. So you can put in your request, or you can just ping me on this number displayed on the screen. And you can, all your queries are welcome. Your if you wish to have these PPTs or anything of that sort, any further contact. So this is my contact number. Thank you, organizers. And now the time for the queries.
Thank you, madam. Participants, you can type your questions in the chat box.
No queries means either nothing is understood, or it is so well understood that you have no queries at all.
Participants, you can raise your questions in the chat box. The session is open for discussion now.
Why we use effect size? Okay, we use effect size so that, likewise, the hypothesis testing initially and traditionally used to tell whether there are significant differences or not. Now, these significant differences, as I told you, that if there are significant differences between the two gender categories, how large the difference is, how much of the differences are being explained by this independent variable, that is measured through effect size. Basically, the differences are important. Equally important is that how large the differences. So basically, these effect size help in generalizability of the studies, determining the predictive ability of the studies. It is majorly in the form of Karl Pearson R or Cohen D, which is again similar to the R of the Karl Pearson. And the criteria there is that if the value is between 0.1 to 0.3, then the study is meagerly contributing. It is between 0.3 to 0.5, because see, R becomes R squared, means 0.3 means only 9% is being explained. So that is not a large effect, right? If it is 0.3 to 0.5, 25%, something is being explained. But if the effect size is greater than 0.5, that is more than 25%, you are actually able to predict in the real phenomenon, in the real world. That is a major output. So that is why how important your study is, and even for your studies to be included in the meta-analysis, to consider it as a quality study, then effect size should be there. It gives impetus to your research and the consideration of your research by the journals or the research organization. Madam, how could we make combination of CSR and SD in single research proposal and sustainable development? Sustainable development goals are there, single research proposal, and how could we measure SD? SD, I think you are supposedly asking about sustainable development, right? So again, review of literature will come to your rescue, that how could we measure sustainable development? There are various parameters given by them, so that you can use those parameters, or you can develop those parameters from the background of economics, how to measure these sustainable development goals. CSR is in fact one of the parameters for sustainable development goals. My email ID is actually, I had written on the last slide. You can take the click of the last slide. I'll just show you. You can take the click of the last slide. I'll mail the PPT to the organizers. You can either take it from them, or you can just mail to me and I'll send the PPT. So you can take the screenshot. Okay, I missed a question over there. Wait. Dichotomous regression analysis. I have doubts. Can you explain, ma'am, again? Yes, dichotomous regression analysis is basically logistic regression or log linear regression over there. It works on the criteria of taking the logs and developing the probability that depending upon the frequency of people in a particular category, users or non-users. Likewise, dependent variable, whether you are using the product or not, whether you are using the internet banking or not. Yes, no, we have the answers in this format, right? So based on the observed frequencies and the response as to 1 and 0 coded in this way, it works on the principle of linear regression extension itself. You can get the relationship that what are the factors which are, what is the association basically between the independent variables and probability of falling in 1 in that category and probability of falling in 0, that is non-user category. Rajendra sir, maybe I'm able to explain it if you can respond. Is your query, the response to your query satisfactory? Dichotomous regression analysis, binary logistic.
Thank you, ma'am. Ma'am, we have not enabled them to interact with you. So
Okay.
they can only chat
So
with you.
thank you.
Thank you so much.
Okay. Any further queries?
Ma'am, we are getting to many questions on YouTube channel also, but due to time constraint, we have selected only few questions, ma'am.
Okay. Thank you.
Thank you so much, ma'am.
Organizers for giving me this platform, and thank you listeners, participants for such humble comments, such positive feedback. Thank you so much. Thank you.
Thank you, ma'am. May I request Dr. Shweta Kalmat, librarian madam, to propose the vote of thanks? Over to you, Shweta ma'am.
Thank you, Shri. Good afternoon, everyone. It is my privilege to propose the vote of thanks. I would like to thank Dr. Ishani Patharia, Faculty of Commerce, Bhagatpur Singh Mahila Vishwavidyalaya, Kanpur, Sonipat, Haryana. On behalf of Government Ramnarayan Chalaram College of Commerce and Management, we thank you, ma'am. The session was very informative and elaborative on statistical tools in business research. And it was very useful to all the participants as well as the research scholars, ma'am. Thank you, ma'am. Thank you so much for your elaborative session, ma'am.
Thank you.
I would like to thank our beloved principal, Dr. B. Chandrasekhar, for his continuous support. Thank you, sir. I would like to thank you, Dr. Ajaz Ahmad Khan, sir. He was instrumental behind this FTP program. Thank you, sir. I would like to thank the advisory board member, Dr. Murlidhar, sir, and Professor Girish BN. Thank you, sir. I would like to thank all the committee members of the program, Professor Sachita Popayama, Dr. Prahlad Chaudhary, sir, Dr. Satisha HK, sir, Dr. Nataraj, Dr. Prakash, Dr. Sri Lakshmi, Professor Syed Rahmatullah, and Professor Tahsin. Thank you. And also, I would like to thank all the teaching and the non-teaching staff. Last but not the least, I would like to thank all the participants who all actively participated in this program. Thank you all. And tomorrow's session is Introduction to Empirical Modeling and Application of Time Series in Business Research by Professor Girish BN. And we hope all the participants should log in on the same time. Thank you. Thank you, ma'am. Thank you so much for your session. Wonderful session.
Thank you. Thank you so much. Thank you, organizers, and thank you, participants, once again.
Thank you, madam. Dear participants, you can fill the feedback form link, which has been posted in the chat box. Thank you, one and all. We'll end this session now.
Good afternoon, ma'am. Please share PPT when be possible.
Okay, sir. Please send me the request through email. I'll do that. Should we end? Should I leave?
Ma'am, we'll end the session program. Thank you.